most advanced bomber in the world, have no tail. That's not just a design quirk. Clue to how the B-2 Spirit became the world's most invisible warplane. If you look at it, no vertical fin, no rudder, no tail like you'd see on a normal fighter. That missing piece, it's not an accident. It's the whole point. Because every radar, and if you're flying deep into enemy territory, you don't want to be seen at all. The B-2 isn't shaped for speed. On radar, on thermal scans, even to the human eye. Removing the tail made it nearly impossible to fly. So how did they haven't other countries built anything like it? The B-2 Spirit doesn't, no tail, no sharp angles, just a smooth, flat shadow. It entered service in 1997, but traces its roots back to the Cold War. Built by men to fly into the heart of Soviet airspace without ever being Air Force wanted a plane that could deliver nuclear weapons without being detected by radar. That goal came with a price tag. Over $2 billion. Only 21 were ever built, and today just 2. The B-2 is so expensive and complex to maintain, it's often kept in climate-controlled in Missouri. But the cost isn't what makes the B-2 special. The Spirit can carry both conventional and nuclear bombs. It can fly over 6,000 nautical miles with 10,000 with a tanker. Its wingspan is huge, 52 meters wide, in the air. And, thanks to its stealth profile, it can get within range of high-value enemy target mobile missile launchers without setting off radar alarms. Set apart even more. Only the United States no country on Earth has ever built anything quite like it. That you're looking at something different is that the B-2 shape doesn't follow normal flight rules. It was built with one goal in mind. So to understand why the tail had to go, it does, and why stealth aircraft want nothing to do with one. Most airplanes have a tail. It's not optional. Those vertical fins and horizontal stabilizers at the back keep it level and stop it from spinning out of control. Think of it like the feathers on an airplane becomes unpredictable. But on the B-2, those stabilizing surfaces are gone, really intentional. And why? Radar. Traditional upright surfaces. These bounce radar signals right back to the like a flare on enemy screens. The B-2's main mission is to sneak into hostile airspace without being detected, and especially vertical surfaces is a liability. Grumman took a radical approach. They eliminated the tail aircraft as a flying wing. The flying wing, just the wing. No fuselage sticking out, no tail in the back. Just one end to end. The entire aircraft is shaped to deflect, not bounce it back. The idea was 1940s Jack Northrop, yes, the same Northrop, experimented with tailless bombers, the YB-49. They looked futuristic, but the technology to control them didn't exist. Onboard computers, they were too unstable to fly safely. Fast forward 40 years, caught up with the dream. The B-2's tailless shape, it also helps to reduce drag, which allows the bomber to that smooth surface cuts through the air without the turbulence caused by tail fin. Intakes are buried deep inside the wing. Even the exhaust is hidden, shielded to reduce its heat signature and avoid infrared. Angle, curve, and surface on the B-2 was designed with stealth in mind. But removing the tail became aerodynamically unstable, in fact, without constant guide. So how does the B-2 actually stay in the air? That's where the next layer of genius comes in, than the pilot ever could. Here's the truth. Without computers, the B-2 wouldn't fly at all. Mine is naturally unstable. It doesn't want to fly straight. It doesn't want to stay level. A chance trying to manually control it, especially at high speeds. That's where fly-by-wire comes in. Fly-by-wire means the pilot isn't directly. Instead, every movement of the joystick or rudder pedal goes into a flight computer, what the plane needs to do, and sends signals to tiny motors that adjust. We're talking about hundreds of tiny corrections every second. Pitch too far up, the computer tweaks elevator and aileron surfaces to nudge it back. Yaw to the left, it might open a spoiler on the right wing to slow it and slightly. Pilot still gives input, but the computer does all the hard math. Because the B-2 has no vertical stabilizers, it has to get creative with how it turns and balances. It uses something which are panels on the trailing edge of the wing that open up like clamshells side of the aircraft, helping it pivot or correct yaw without needing it. Spoilers, which pop up to disrupt airflow and slow one wing during a turn, giving the aircraft even the thrust from the engines as part of the steering. If more power is pushed through the left engine, the bomber veer to the right, like paddling a canoe harder. This is handled by the aircraft's central flight computer, using sensors, gyroscopes, and algorithms that constantly predict, and pilot even notices something's off. It's not just smart, it's essential. Without this system, or a crosswind could send the aircraft into an uncontrollable roll. But with it, the B-2 glides smoothly, even. Its biggest strength is its radar evasion, because there's no vertical stabilizer. Waves don't bounce back to the source. Instead, they scatter in other directions. That makes the B-2 nearly invisible. Its radar cross-section is often compared to that of a large bird, or even a small, because it's tiny, but because it looks that way on a radar screen. Even advanced radar stations may only pick up a vague blip. Then there's altitude. The B-2 flies high, typically above 50,000 feet, and strike without ever coming close to enemy defenses. And be flying low through valleys or hugging terrain, it can conserve fuel, fly straighter, and stay airborne longer. On a single tank of fuel, the B-2 can nautical miles. Add mid-air refueling, and it can circle the globe. That's why the US can launch a mission from the Middle East and return without ever landing abroad. Carry 40,000 pounds of weapons, both conventional and nuclear. Its bomb bay is configured to handle smart bombs, stealthy cruise missiles. In a real-world mission, the B-2 doesn't just sneak in, it appears again, sometimes before enemy commanders even realize something was coming. All of this without firing a shot. Dogfights, no flares, just precision from a distance. And that ability to deliver overwhelming force without it takes the B-2 more than just a bomber. It's a ghost with teeth. But, for all, the B-2 isn't perfect. Let's start with the obvious. It's extremely hard to fly without. It is aerodynamically unstable by nature. If the flight control system goes down, able to control. There's no manual backup. It's soft. Then there's the cost. Each B-2 costs to build, more than most Navy destroyers, but that's just the beginning. Maintaining a B-2 is like condition. Every flight demands hours of maintenance. RAM or radar-absorbent material has to be checked and often reapplied. Even a small crack or panel miss a larger radar signature. It also needs special climate control, because humidity and dust can damage the stealth surface. The paint isn't just paintability. And then there's the maneuverability. The B-2 isn't fast. It cruises at subsonic 30 miles per hour, or 1,010 kilometers per hour. That's slower than most fighter jets and war bombers like the B-1 Lancer. It also doesn't turn sharply. There's no air combat agility here. Fly high and far. And then finally, in daytime operations against a clear sky, it's not totally invisible to the naked eye. And once detected, it has no guns, no missiles, just countermeasures and... So while it's nearly untouchable in a stealth mission, it's vulnerable if caught off guard or flying alone in the wrong air. Missions are carefully planned, often at night, with full support from tankers, satellites, and reconnaissance assets. Invisibility, but it comes at a high price and with high stakes. The B-2 Spirit won't fly. Successor is already in the sky. The B-21 Rance. The B-21 looks almost identical. Same flying wing, same smooth curves, no tail. But under operation. Developed by Northrop Grumman, the B-21 was officially unveiled in 2022. It's designed to be easier to maintain than the B-2. While the B-2 required the B-21 uses modular systems and coding and cheaper. The B-21 is also built with China and Russia in mind. It's in high threat zones with improved survivability. 23 and the US Air Force plans to buy at least 100 Raiders. That's 5 times ever made. But even as the Raider takes flight, its design owes everything to the lessons of the B-2. Profile, same flying wing, and still, because in the future of warfare, being seen is the... So why does the B-2 bomber have no tail? The tail of an aircraft reflects radar. It gives the enemy a place to lock onto, a place to aim. The B-2 doesn't give you that chance. Its shape bends radar waves, its surface absorbs them, and its entire flight path is designed not to impress, but to disappear. It makes up for with reach and silence. It doesn't need to fly fast, it just needs it does. For over 30 years, it's been the only aircraft in the world that can fly straight into defended airspace without ever being tracked. And now with the B, that legacy continues, with no tail and even fewer traces. But now we want to hear from you. Will ever catch up and build something to match the B-2? Just too far ahead? Let us know in the comments. And the channel directly, join the fleet. You get responses and you help us bring more true aviation and maritime stories to the surface. Click join on our channel page and get on. Stay stealthy.